Give it up for Michele.
Okay, hi everyone, can you hear me okay? Excellent. So yeah, my name's Michele Titolo. You probably know me mostly from CocoaPods. I'm also CTO and board member of Women Who Code. We're based in San Francisco, and we're a nonprofit dedicated to empowering women to excel in technology careers, so that's lots of fun. But I'm not here today to talk about any of that. In fact, I'm here to tell you about the past 3 years I've been doing consulting. So I have released a lot of apps. I lost track at about a dozen, and I counted like 5 or 6 months ago. So I've built a lot of code, but one of the things that you do a lot in the consulting world is you inherit code. So that's what I'm going to talk to you about today. And one of the themes that I want to keep going with as I go through this talk is I think of code as an art form. Code is very creative. Writing code is very creative. There's always an audience involved that you don't know. You don't know who's going to download your app. So when most developers inherit a code base, they expect to see something that is amazing, that is a masterpiece of code. Because obviously this app works, it's great, people like it. So it must be fantastically written, must be easy to use, code must be well documented, all of these things. But in reality, what we get looks a little bit more like this. So I'm going to be going through and giving you some tips, tricks, and the how-tos of what to do when you're looking at a code base for the first time. So the art of code. Every time you look at a code base, you have a purpose. And it is usually a problem you are trying to solve. You could be fixing a bug. You could be adding new features. You could be updating an API. Identifying your focus and your purpose is very important when you're looking at a code base for the first time, because it helps you narrow down. You don't want to be going out into a sea of code and you have no direction where you're going. You need a compass. So first things first, right? Let's get in. We have code. Does it build? Yes. Let's check if it builds. No. You don't want to start just by building the code. And I'm going to spend most of my talk actually not talking about code. Because you will learn a lot about code before you press the build button in Xcode. Because writing code is inherently a human process. It is about teams, it is about people, and it is about time. So you need to kind of see the history of your code. Look at the painting, see when it was painted. Was it Van Gogh when he entered into the mental asylum and all of a sudden his paintings went from brilliant colors down to muted tones? So you need to figure out the meta information. And these are normal questions that you think of every day. Who, what, where, when, why, and how. The why and the how are the really meaty, important points. They're the actual code. It's why did they make these decisions? How did they make these decisions? But who, what, when, and where, this is what I'm going to spend most of my talk on, because these are the really important parts. You can save yourself a lot of time by spending an hour or two digging into the history of your code and seeing what's happened in the past that can inform you when you're actually looking at the code and seeing, well, why did they make this decision? So who made your code? There's a couple of different ways you could figure this out. Source control is an obvious one. Git log. Everybody loves git log, looking at previous commits if you have a GUI. That is awesome, because then you can just go through, see how many people, where were they, do you know them? Because if you know someone who wrote down this code, your life's going to be a lot easier. So how many people? We all know the more hands on a code base, the less likely it is to be a beautiful masterpiece. It kind of gets a little fragmented with people kind of claiming their stake in the code base. So that's a good thing to know, because the more people, the less likely it's going to be very coherent. Are all the commits by one user? I've inherited a couple code bases, and I'll tell a couple stories. But one code base in particular, it turned out that the dev shop we inherited it from, everyone in that company had one Git username. So it was all the commits were by this dev account. So you had no idea who made any of the commits. You had no idea. It was just all whitewashed. Are there useful commit messages? Yes, look at commit messages. These are really important. If you see things that like you have 4 commits in a row, that's like, oops, oops again, sorry, that's not really useful. If everything has been squashed, so there's like one giant commit, that's also something you really need to know. Xcode file headers, also really helpful for this. We all know what these look like. It's the default Xcode headers that every time you create a new file in Xcode, it will add it for you. It will put your name and it'll put the organization name, whatever that is. Easiest way to check for these is to find in project. Everyone knows how to do that. I've also loved using grep on the command line because you can pack in a nice little regular expression and play around with it and see different files and folders and see if one person was writing code in one folder only, for example. So were files mostly created by one person, so you're working with a single developer, so that means things should be fairly coherent. Are there all sorts of people creating files in this code base? You don't know what the process of this other team was that built this code, so it might be that there's 3 people and they're all creating files, but they had meetings about it and they had an architecture document, but you don't know that. So you don't want too many cooks in the kitchen. That's a very old adage, but if you've seen so many people, if there's 15 different names or 17 different names, then you might be getting yourself into something that's not what you expected. So now some stories. So 2 things that I've seen. 1 shop, 2 shop, red shop, blue shop. That was kind of funny. And so bifurcated code. So one of the first code bases I inherited, it was back in 2011. iOS 5 had just come out. And we inherited a code base that was written for iOS 4. And we were the 3rd development shop to inherit this code base, so the 3rd people that we knew about that had touched the code. So what happened when we looked in it? Well, they wanted to do some things, so we went in, started taking a look. And it turned out that there were 2 distinct parts of the code, especially related to server interface. So there was one set of classes that would make web requests and have a delegate and come back to your view controller. There was another set of classes entirely separate that would post notifications. And you'd have view controllers that would actually use both of those classes intermingled. So it was a big pain in the butt, because the first thing we ended up doing was going through and ripping all of that out, because the code was really confusing. You didn't know if this screen was being loaded by one or the other. Breakpoints helped, but QA is not usually the best at telling you exactly what part of the screen if there are multiple API requests. So fun story, notifications, protocols, be careful. If you have code that is, if you don't have a Git, if you don't have version, if there's no names in the headers, this also tells you about who wrote your code. One client that we had actually had us strip the copyright from all of the default Xcode headers, put in their own. They had us print the code, and then the code was copywritten by a lawyer. Yes, I have had copyrighted code. So this tells you if there's no source control history, if you can't tell who wrote the code, it's either a very secretive person, in which case that can tell you that they might not be very open to discussing what's happened in the past, or they might not care. I've seen this happen too, where they're just like, we just want you to make these 3 changes, please don't touch anything else. And you're like, but there's problems. We want to make code better than where we started. So even if there's no idea of who made this code, you can still kind of tell what's happened to it. What does the app do? What does this code base do? And this is just using it. I've inherited lots of code bases. Several times I've actually made the mistake of looking at the code before actually playing with the app. Let me tell you, it makes no sense when you do that. There will be things you don't understand until you use it. This is any user experience. This has to do with, are there really fancy custom animations? Does it happen to download 60,000 pieces of data when you start it up? You won't necessarily be able to tell that when you're just looking at the code. So this is a screenshot of a core data model file that I once worked with. There's some entities I think that are off the screen still too. This app had over 20 core data model entities. And when I first looked at it, I had no idea what it did. It turns out this all actually makes sense. believe it or not. But it was not the easiest thing to think about. I've done a lot of e-commerce work, so e-commerce apps, there's like products and users and like reviews, and you have very few models. This one was not the case. My coworker and I, we sat down and we had a 2-hour-long conversation with the guy who wrote the app. Because there were concepts here that neither of us were familiar with, that we'd never experienced before. It was like a sports gambling kind of app, and I don't know how to make bets on sports games. I've never done that before. So it took us a long time to understand how to use the app, and also how we can think about the code now that we know what the app is, because no one wants to work with things that look like this and not know, why is this thing connected to that thing? I don't understand. It can give you a lot of insight. So use the app. But you also need to ask questions. If you're going to be working on something, as Luis said earlier, we're the translation between the end user and the code. So if we don't understand what's supposed to get translated, we can't write our code properly. So you need to ask lots of questions. Most importantly, to figure out edge cases. We're human, we make mistakes. We don't think that we need an empty state for something sometimes. You think that the user is always going to be online, connected to internet. Because you're going to have to deal with all of the edge cases. You're inheriting a new code base. This is brand new. You're going to be changing things. And the last thing you want to do is have someone go out and test the app, and they're like, hey, it crashes on launch when this, because you don't want that. You need to be really careful. Oh, and by the way, you should write everything down. Notes are your best friend. I've done this on apps where we updated the app. It was 3 or 4 months on another project, and then went back to that first app. And because we had notes and we had written down and we documented what we'd done, it was really easy to come back to the code after 4 or 6 months of not working on it. And future me thanked past me for writing notes, because then I was able to say, hey, there are these edge cases. Hey, we didn't fix this yet because of this reason. Please fix it the next time you can. So that is the what, when. The most important thing when code was written is, what iOS version was it written for? Is it using Arc? Because if you're in the consulting game, you will find some apps around that still don't use Arc. So what version was it built for? iOS 4. I had this app last fall. We didn't end up working with the client, but I was the lead engineer at my last job, so it was my job to kind of look over code before we signed a contract to make sure that it was doable. We had this one app that came in. I was told to do a code review. And it was built for iOS 4. Didn't use Arc still, and this was the fall. And they were like, we want to update this for iOS 7. Last fall, iOS 7, pretty big deal. And it was an iOS 4 app. Did not have view controller containment, did not have UI appearance. In fact, they didn't even use the native tab bar. They created their own custom tab bar. And they'd done all of this custom work, and it was one of those that had been kind of handed around after a while. So 3 or 4 different companies had touched this app. And it was a mess. We estimated to do the updates they wanted to, it would have cost them several $100,000, because we would be getting most of the UI layer, simply because you can't make it work. So be careful when you're looking at really old code, especially when they're like, oh, this will be an easy update to iOS 7. Not necessarily. Nothing's ever as easy as you think it will be. Backwards compatibility. We all know Apple's pushing iOS 7 on everybody. iOS 7, iOS 7. Everything Apple seems to say these days is iOS 7. But you can't always do that. I did an education app, and everyone that was using the app was using iPad 1s. There will occasionally be a client where the CTO has an iPad 1, and the new release goes out, new beta build, and someone really high up executive is like, I can't run this, I can't test this. So you need to be careful about backwards compatibility, but you also need to be careful about what the app is currently doing to support it. So is it using any new things? Is it going to compile and be backwards compatible with iOS 5, but actually crash when you use it? How is it checking the version? we all know there's a couple different ways of doing this. Some people make macros, some people do a call to UI device. There's all of these different ways to check versions. Hopefully the app's only doing it one way. I've been in the case where the app did not use like one thing to check version, and it was like over here and over there and over there and over there and over there. And that's a problem, because then now you need to go back and change it in all those 5 different places, and hopefully make it just one thing, but you still need to be careful. And the further back, the older the code, the more problems you're going to have, because iOS has changed. Where in 2014, iOS 7 was a huge change for a lot of us. Apple introduced a lot of new things. A lot of new things were fixed. Things where some of them were broken, but a lot of things were fixed. So you have to be careful about how old this code base is. You might want to reuse models. You might be able to reuse some of the storyboards or nibs, if you're going way back there. But just be careful of how fragile the code base is, because it's so old. Another thing, if you have source control history, were there gaps in development? I was told this one story by another contractor who was hired by this one company to add like one feature to an app. And this was, the year had passed since he'd done that, and the app still hadn't been released because the client kept going around to different contractors, different development shops for just one more feature. And they ended up doing that for a year, which is a problem. But also, if you're doing client work, a lot of the time, client will like come in, yes, let's make an app. We're going to do mobile first. And then they release the app. Your contract ends with the client goes away. And then the app doesn't get touched, because the company hasn't invested in mobile as a part of their normal development process. So you need to be careful if like 6 months, a year, 2 years has gone by since this code base was touched or updated, because that's a long time. That's a lot of bugs. 2 years is a lot of time for bugs. So if months went by, find out why. Did someone quit? Was there a budget problem? Years? Yeah, no, you probably don't want to deal with that. And this all comes down to technical debt. We love and hate this term, because when you inherit a code base, you inherit technical debt. And it's not debt that you created, it's not debt that you had control over, but now you have to deal with it. And hopefully it's not terrible. I know I'm sounding very pessimistic right now, but it can be really fun, because you have all sorts of really new and interesting challenges that you've never experienced before. I'd never worked with a core data model that had over 20 entities in it. It was an experience, and it was really awesome to be able to do that. Where was this code made? Was it contractors, in-house, or in a shop? I've done consulting at a dev shop, so that's my experience. So one of the things that I've learned to ask lots of questions about is if an app was in-house and then all of a sudden the development went out of house. Because usually that means there's some sort of politics going on that you should also be aware of, because you don't want there to be like a silent partner that swoops in the last minute and is like, we can't ship this for whatever reason. So you want to make sure you get an idea of who everyone is involved in, and like, you know, if someone else had been working on the code internally, what are they doing now? Contractors, there's a lot of apps. Like contractors, there's a ton of them. There are a lot of really great ones. I know there's a lot of really great ones in this room. But you know, if you can find out who they were, that would be awesome, because then you might be able to ping them every once in a while, or just you might have an idea of the kind of code that these people write because of open source or any other reason. If you don't know, that's cool too, but it usually helps if you can at least figure out. And then Debshops. We all know kind of the big ones, but there's one specific point I want to make about Debshops is that, and if they're outsourced. And what I mean by that is specifically, your code was not written by someone whose native language is the same as yours. So that if you're a native German speaker and you're inheriting a code base from someone who is, I don't know, American and speaks English, that might be a bit more of a challenge to you. So yeah, you want to be really careful about that. Just because things might be spelled differently, they might do different things simply because it's a different world for them. So this app with the crazy core data model, there are a number of really strange things about it. And one of the weirdest things was there were these table view cells. And there was a table view cell had a subview that had a subview that had a subview that had a subview. And then the text was finally drawn with draw at point. This app was written for iOS 6. And it took me I found out about a month and a half into working with this app that the previous developer, it was, first of all, his first iOS app ever, which would have been nice to know, but also he came from a C background. So I was looking for Objective-C development patterns, and I was not seeing them. So another thing, I've heard a lot of British and Canadian and French people complain about stuff like this, color versus couleur. So just be careful. Just be careful. It's the same word, but I know some people try and type UIKonf, and or you might have weird, like, if you're looking at a category, it might say UIKonf instead of color. I just thought it was kind of funny. But also, when it comes to where internationalization, is this app localized? Where is this app currently on sale? That's really important, because if you're going to have to deal with localization, if you're going to be going between Japanese and German, you're going to need to know that, because there's going to be things that you need to change specifically to handle the fact that in Japanese it's got really, really tiny, and then German is like really, really, really long. So that's what languages are supported. So that was the who, the what, the where, and the when. And now I'm actually going to talk about some code. This is the fun part. So why was this app built? Well, we just covered that. You should be able to know who the company is, some idea of who built it. You should know what the product is. You should have a good idea of the things you should expect this app to be able to do. And don't just jump to conclusions. So you have the why, you know why this app exists. So now that you know really well what is going on everywhere else, you can actually start digging into code. So how? First thing I usually look for is the file structure. So Xcode, how are the files organized in Xcode versus how are they organized in the file system? If it's someone's first app, for example, they might just drag things into Xcode, and then everything's in that main file, and you have like view controllers and controllers and storyboards and images andplists, and everything's in one file in that folder, and that's just not fun. So you want to be able to see how the things are organized, because that's going to tell you how someone thinks. If they've separated their header files from their implementation files, for instance, that might be very different from how you develop, so I know I always get confused when I see that. Images are also really important. How are they named? Is there a consistent naming scheme? Is it like, do they actually do that 2x properly? Yes, that can be a problem sometimes. And then kind of make a map, whether it's mental or just written down somewhere of like, if I need to find something, where do I go? I know in Xcode we have quick open, but if you're looking around on like a Xcode or like a GitHub or any of the source control GUIs, you're not going to be able to quick open. So you know where things are. And now we have building. Everybody's favorite thing, we love pressing that play button or Command R. So does it compile? Yes, I've gotten source code that doesn't compile, because it doesn't always. And that usually happens when it's missing dependencies. You'd be surprised how many people will not remember to send the pod file, or have a private submodule that you don't have access to when you get submodule update --init. So you need to make sure that you can actually build the code. It's very important that you can build the code. I think everyone in this room can agree with that. Are there weird build settings? This is something that's a little bit harder to see, but if you kind of go through the project file looking at what the build settings are, is there an xcconfig file just hanging around somewhere that is not like a CocoaPods one that someone just created? Because people can do weird things with build settings. It could be using a different compiler. If they were using an older version of Xcode, it might not have ARM64 support now. So there's a lot of things to look at. Warnings, everybody's favorite. So how many warnings are there? I've inherited code bases that have over 50. Yes, over 50 warnings. We did not treat warnings as errors. You should check that too. But usually, warnings in the code bases that I've inherited, the more warnings, the older the code base, because a lot of them are deprecation warnings. This thing is going away, this thing you shouldn't be doing. So that can also tell you how old a code is. How terrible are they? Because we all know warnings have different levels of things, whether it's, oh, you should cast this to a long, for instance, or, oh, by the way, you should not be using perform selector anymore. Pragma warnings, I love and hate seeing these in code. I personally use them when I want to make sure that and I have treat errors as warnings turned on, and then I use this guy to make sure I fix something. You should see if someone else does that too. But if there are, warnings, you should check them, see what they are. Comments. Everyone loves comments. I've seen a lot of fun comments in my days. To do, fix me, question marks, curse words. Are there paragraphs worths of comments? I've actually had one code base where there was this one file where it must have been 60 to 70 lines in the entire file. More than half of that was a comment block. So that just sent a red flag off saying, if something is this complicated, one, why are they documenting it in the implementation file? And two, why isn't it a README? So are there documentation? There's no excuse for not writing documentation anymore. If you know the kind of work I do with CocoaPods, I'm in charge of all the guides and documentation. So there's no excuse. There are plugins in Xcode that will format it for you perfectly. So obviously headers, if documentation, so documentation in the headers, yes, please. If it's in the implementation, why are you putting it there? No one ever reads that. So READMEs are also great if you use Git, because then everyone sees them. And then there's this PCH that you have to kind of be careful of. One of the last projects I worked with was, I worked with threadless.com on the 2 releases, and I was in charge of one of the apps, and there was another team doing the other one, and I looked at their PCH file, and they had imported about 20 different things into their PCH. I don't like that. That means that even in your model files, you're getting UI included. All of your categories, everything was being imported everywhere, which I don't necessarily like. But that also can kind of tell you that someone was not very careful in figuring out where this thing was actually needed. They're just kind of like, oh yeah, we'll use that everywhere. Some stuff you will use everywhere, but not all of it. Tests. This wouldn't be a slide about inheriting code if I didn't talk about testing. If there's no tests, you will need to write tests. Trust me, the last thing you want to do is go into a brand new code base, start changing things, and then start breaking things. And the best way to prevent this is write a test. And that doesn't mean you start and you're just starting to write tests for everything. It's going through, you're changing a model, you're changing logic, write a test, and then do your changes, and then make sure your changes don't necessarily break anything. Then dependencies, obviously this is a big thing. We've heard a lot about CocoaPods. CocoaPods are awesome, but there's a lot of companies that still use submodules, so you have to know about those. CocoaPods are great. I love CocoaPods, but also be careful that there are not like 50 CocoaPods. The last thing you want is like a Frankenstein app where someone was going through and like, oh, that's the progress bar, I'll take that slide view, that's the accordion table view, oh, there's this thing for core data. And then you're just putting the pieces together of all of these apps that might not be done in a very useful way. And then just see what else is weird. I've seen a lot of crazy things in code bases. I've worked in Objective-C++ unexpectedly, because build settings. And so there's a lot of unknowns. And what I'm talking about is the art of code. And just like anything else, once you know the who, what, where, when, why, and how, you can go through this code base and figure out what's going on. Art takes time. I don't know any painter who can say, I'll be finished with this in a day. There are some artists that say their paintings are never actually finished. Art takes patience. Brushes are tiny. I mean, there are some artists that will do the big things, but they think about things really, really hard. And code takes time. It's something that is an art form, and it is very creative, regardless of what schools and universities would like to tell you, because we're making computers think like humans and act in ways that, help people and respond to people. Code also takes patience. Don't be judgmental about code. Don't get angry at code, because it's not the code's fault. It is nobody's fault. Everything gets written in a time and a place, and you just have to kind of live with it and figure out how to move forward and make things better. So I hope you all move forward and make things better. Thanks.